This is Navodit Aditya. Welcome to my channel NAditya83. In my last video, I have shown you how to find out the velocities and accelerations of a point in the rolling motion kinematics. I have discussed about the theory of rolling motion. Today in this video, I will exemplify it with an example with a problem in hand. Let's see what is the problem. It is saying a sphere rolls without slipping with velocity v0 about its center of mass and angular velocity omega. What is the distance moved by point A as shown in time t in the linear direction? So actually they are saying that it is rolling without slipping, means there is enough friction on the ground to support this rolling. The center of mass is moving forward with velocity v0. It is having an angular velocity omega. How far will this point A move in the forward direction in time t? This is the question. So if we write down the given parameters, it is, suppose, let's set our frame of reference. This is x-axis, this is y-axis. v0 velocity is actually vector is v0i. Omega, as I have shown in the last video, is a vector quantity and it is given by omega of minus k, which is in the negative x direction. This point A, suppose this was the initial position. This was the initial position of A. After t time, it moves through an angle theta equal to omega t and comes to this point. This is the radius r, this is the radius r, is a given parameter. So this is the angle theta, which is theta equal to omega t, moved by point A. So in this time, as it rotates from here to here, how far does it move is our question in hand. I think it's clear to everybody now. Now suppose when the point comes to here, suppose it is A, the velocity of point A, VA, is given by VC plus omega into RAC. Actually this is the vector cross product between omega and RAC. Here we are trying to find out the velocity of point A with respect to this center point C. This is the center C. Omega is the angular velocity and this is RAC vector. If you want to know how this relation is derived, please refer to my last video. Moving on, we can write it like this: VA vector is equal to V0i, as VC is V0, this is the center of mass, plus omega minus k vector, cross producted with RAC. If this is theta, alternate angle, this is also theta. So if we break this R into vertical and horizontal components, this is R cos theta and this is R sin theta portion. I think everybody is clear to it. This is the R cos theta, this is the R sin theta. So I can write it as R cos theta, this is coming down in the negative direction, so it is minus j, plus R sin theta, this is going in the negative x direction, so it is minus I. I am repeating, this RAC vector is R cos theta in the negative y direction and R sin theta in the negative I direction. Now let us complete this vector cross product. Minus k cross minus j will give minus I vector. And minus k cross producted with minus I will give plus j vector. just taking the I portion in one hand and the j portion in another hand. Okay, now we have written theta is equal to omega t. So velocity vector A is equal to v0 minus omega r. We are replacing theta with omega t. Okay, I think this is clear to everybody. This is the thing. Again, we can write it as VA is equal to. Now, the most important thing, as I have shown you in my last video, that in rolling without slipping, the relation between the velocity of the center of mass and its angular velocity is given by this relation. V0 is equal to omega r. So we can replace this omega r here and here by V0, and taking V0 common, we can write it 1 minus cos omega ti plus V0 sine omega t j. Right. So this is the velocity vector of A. If we need to find out the magnitude of the velocity, we know there are two perpendicular components. So VA vector equal to square root of V plus V0 square sine square omega t. I think this is clear with everybody, because if there are two perpendicular vectors, so resultant vector mod of resultant vector is root over a square plus b square. This we all know. So taking v0 square common out of the root b0 and expanding this becomes 1 minus 2 cos omega t plus cos square omega t plus sine square omega t. Right? This portion cos square omega t plus sine square omega t will give 1. As we know from trigonometry, basic trigonometry, sine square theta plus cos square theta is 1. So this one and this one gets added up and becomes 2 minus 2 cos omega t. We can take a 2 common, 1 minus cos omega t. Now 1 minus cos theta, as we know in submultiples, is 2 cos square theta by 2. Another trigonometric relation, we are using it here. So it becomes V0 2 into 2 cos square omega t by 2. I think this is clear to everybody. I'm sorry. This will be actually sine square theta by 2. 1 minus cos theta is sine square theta by 2. So it becomes sine square cos omega t. I will write it clearly once more. Sorry for the mistake. 2 into 2 sine square omega t by 2. Right? So this becomes 2 b0 sine omega t by 2. So this is the mod of velocity vector of A, the magnitude of velocity vector. Now if I have to find the distance moved by this point A in this time t, suppose let it be SA. If SA be the distance moved, we can show that SA is given by VA dt integral VA dt, because the whole thing is moving with uniform velocity v0 about its center of mass. It does not have any acceleration. The point here has acceleration, which is the centripetal acceleration only, The magnitude of the velocity remains unchanged with time. So we can use these relations very clearly, that the SA is integral VA dt. We can integrate it from within the limits 0 to t. VA remains unchanged with time, 2V0 sine omega t by 2 dt, integral 0 to t. So minus cos omega t by 2 by omega by 2. I think everyone knows sine, integral sine mx dx is equal to minus cos mx by m plus c. Using this integral here, it's 0 to t. I think everybody is clear. Before I turn over the page, just have a look once more that it is integral VA dt 2V0 integral 0 to t sine omega t by 2 dt. Integral sine omega will give minus cos omega t by 2. So it becomes omega by 2. If you want me to write it down once more so that you can follow it, is 2V0 minus cos omega t by 2 by omega by 2 0 to t, right? So just solving it now, we are almost over. 2 by omega cos omega t by 2 0 to t. If I take 2 common, it's cos omega t by 2 minus cos, when we put 0 it becomes cos 0 minus 0 is minus 1. I think this is clear with everybody. I have solved the equations, I have solved the relations in step by step, and I think you can follow this relation. So this is the final answer. The distance moved by the point A in time t as the figure rolls, as the sphere rolls, and this is our objective answer. So as it moves through an angle theta, it will move a distance SA, which is given by this. This is a direct application of what we have done in rolling motion kinematics, finding out the velocities and acceleration. And if we know, we can also simplify it in another form, as suppose if V0 equal to omega r, we know V0 by omega can be written as r. So this is simple 4r 1 minus cos omega t by 2. Thank you for listening to me. I think everybody has followed the equations. Just go through the lines one more. If you want to copy it down, just follow the equations and the instructions. I will come back to you once again with another problem, with another challenging problem on rolling motion. Till then, stay tuned. Get back to your syllabus. Have a good sleep. Till then, goodbye.